Thank you. I had hoped to talk about death, life, and the experience of community today in a way that I thought would hopefully be appropriate to the occasion, but didn't quite get over the line with that. So the paper I'm going to give actually has its origins in the second conversation I ever had with Nancy, where I was trying to pin him down on the status of sense in his philosophy. And unexpectedly, he started talking about philosophy of nature and cosmology, referring perhaps to some of those passages in the Sense of the World that have been referred to. And I didn't know what to make of it at the time, but retrospectively, it's clear to me that he responded to my rather sort of picky and no doubt reductive questions with a typical generosity of thought. And although I didn't really follow up on that, certainly over the last 10 years or so, on and off, I've been trying to follow through the implications of that conversation. And this paper really is a response to that memory of that generosity of thought back then. So what follows will trace a trajectory from what can be called modernist science through to Nancy's philosophy and his interaction with the cosmologist Aurélien Barraud. It will argue that the legacy of modernist science may be a resource for thinking with Nancy, a distinct variant of relational realism that sets his philosophy into an alignment with strands of contemporary scientific thought. Nancy's philosophy, I argue, shares many of the concerns of modernism and indeed of modernist science. These include a preoccupation with fragmentation and, along with this, an emphasis on multiplicity and plurality. Most significantly, fragmentation and plurality are articulated in an understanding of existence, which is relational, and in which relation and relationality are themselves originary. Notions of substance and ground give way to an affirmation of ontological void and groundlessness, since relationality as such does not offer any kind of foundation. At the same time, though, if the real is relational, then it is always of necessity in relation. And it is in this that relational realism of any kind finds its orientation. So from the beginning of the 20th century, the relational understanding of being is, of course, by no means alien to science. It is present in a distinctive and decisive manner during the modernist period that spanned the first 3 or more decades of the 20th century. The most obvious points of reference here are, of course, Einsteinian relativity and quantum mechanics. But looking beyond the more obvious references to Einstein and Heisenberg, it is in fact the thought of the mathematician, theoretical physicist, and philosopher of science, Henri Poincaré, that can be seen to exert a decisive influence throughout the modernist period. As a practicing mathematician and scientist, Poincaré was not trained in philosophy, but he was very well informed in relation to current philosophical issues, in particular those which concern science and scientific epistemology. What has been characterized as the modernist character of Poincaré's approach is most explicitly indicated in his geometrical conventionalism and its concomitant relationalism. Poincaré argued in his 1902 work, Science and Hypothesis, that, I quote, "We have no pre-axiomatic understanding of geometric primitives, and that when we speak of space, all we can talk about is the relations of physical bodies." On the face of it, Poincaré's position might appear to be Kantian, insofar as conventionalism in geometry, and therefore in the geometrical apprehension of physical reality, might also be understood as a variant of scientific constructivism. Poincaré was without doubt influenced by the neo-Kantianism of his milieu. Yet there is a distinct absence of philosophical foundationalism in Poincaré's conventionalism, and the a priori status of conventions is by no means pure. The axioms of geometry, Poincaré notes in Science and Hypothesis, again I quote, are conventions. Our choice among all possible conventions is guided by experimental facts, but it remains free and is limited only by the necessity of avoiding all contradiction. In fact, rather than a pure idealism or a priori philosophical foundationalism, there is arguably a pragmatism at play here, one that is situated in between empiricism and a priorism, and according to which the choice of geometrical convention, the empirical real, and an applied rationality that abhors contradiction combine contingently to co-constitute the object of scientific knowledge. Importantly, Poincaré does not appear to be interested in laying metaphysical or universal a priori foundations. Indeed, he is clear that when it comes to space and the location of points or objects in space, there is no primitive orientation or absolute positioning of said points or objects. All that can be said of these arises from the axioms we ourselves have chosen. There is, in Poincaré's geometrical thought, an absence of an originary, absolute, or primitive orientation within space. This implies an equivalence between the multiplicity of new non-Euclidean geometries, and with this, an irreducible absence of overarching or unitary metaphysical foundation. Geometry does not give us a truth about an already known object positioned in absolute space. Rather, it is just a system of relations. Here, in the context of scientific and pragmatic or experimentally oriented scientific theory, the key ingredients that can be associated with modernism are unambiguously present. The fragmentation of overarching unity, the irreducibility of plurality, the affirmation of thoroughgoing relationalism, and along with these, the absence of any primitive foundation or ground. Poincaré's influence within the realm of wider modernist thought and aesthetics was far-reaching. His well-documented influence on Cubism, for instance, might most obviously and directly be cited in this regard. More broadly, conventionalism implies a pluralism of possible orientations towards what can now be understood as an irreducibly plural real. This is paralleled within the wider sweep of modernism with an open-ended and experimental proliferation of new forms and ways of grasping, conceptualizing, and representing reality on multiple, at times incommensurate levels, based on a profound recognition that reality itself is irreducibly incommensurable. What is perhaps at stake here, decisively, is the way in which, within modernism, philosophical discourse, scientific theory and experimentation, as well as aesthetic production, can all be understood as different techniques, insofar as they apprehend different aspects of a fragmented, multiple, and non-unified reality. They are themselves irreducibly plural as modes of technique. In his introduction to the Cambridge Companion to Modernism, Michael Levinson not only attributes the recurrent act of fragmenting unities to the common devices of modernism, but also a general preoccupation with technique in relation to material and aesthetic forms. By technique, here is to be understood the material technicity of any given form, the fact that I quote, every element of the work is an instrument of its effect and therefore open to technical revision. This recognition of the material technicity of aesthetic forms leads Levinson to ascribe to modernist culture a regime of technique and a passion for technique. Arguably then, the notion of technique, understood as a material technicity of form, which is declined always in the plural, offers the key to understanding the way in which, within modernism, ontological fragmentation, groundlessness, and plurality were articulated. A concern with technique is a central preoccupation of the most prominent French philosopher of science in the interwar years, Gaston Bachelard. Bachelard's work itself is firmly rooted back within the tradition associated with Poincaré, and his concept of phénoménotechnique can also be understood as a critical response to the conventionalism of Pierre Duhem and Édouard Leroy. Bachelard can be taken as a key staging post within the interwar years in a trajectory that leads from Poincaré's modernism through to the structuralist and post-structuralist thinkers of the post-war decades, and then on to Nancy in the last decades of the 20th century and first decades of the 21st. Bachelard's 1934 work, The New Scientific Spirit, contains many of the key elements that have been encountered in the context of Poincaré. He affirms that the plural relationality of given phenomena requires a plurality of method or technique. That is to say, he affirms the necessity of technique as the means by which reality can be determined. Similarly, Bachelard, like Poincaré, sees in mathematics and geometry a purely relational way of knowing space. This in turn leads him to affirm that fundamental, that is quantum, reality is itself purely relational and not composed of objects or things, as when he argues that objects only have their reality in their relations. That's a quote. In Bachelard's universe, then, there are no primitive substances or substantive entities that would ground our understanding of the being of being, only relational forms. As Dominique Lecour has pointed out, Bachelard's position is radically anti-Kantian and, in a perhaps unusual manner, realist and objectivist. What is at stake here is an applied rationalism, according to which scientific knowledge is constituted in a relationship between a non-human exteriority that imposes itself on our experience and upon the rational constructions or conventions that are embodied in material experimental technologies and techniques. In his 1949 work, Applied Rationalism, Bachelard redefines the Kantian noumenal and suggests that the real, far from being unknowable, is always imposing itself as a corrective to our existing constructs. The real is therefore known in this corrective relation of imposition and through the production of new phenomena that result from those corrections. As Bachelard himself puts it, this is a quote, "The real is a mass of objections to already constituted reason." This then is not an idealism, and it is here that the notion of phenomenotechnique takes on a decisive importance. For Bachelard, scientific knowledge and its objects are experimentally produced in a combination of rational and theoretical form and experimental technical activity. Quote, "All primary experimentation must first be transposed into a domain of rationality in order then to be reposed as an element of a realist technique." Dominique Lecour puts this in the following terms. Bachelard proposes without equivocation the thesis that the truth of scientific truth imposes itself by itself. This means that it does not need to wait for a philosophical foundation or guarantee. What this means is that Bachelard does not impose an idea of the limits of knowledge or a separation between the phenomenal and the noumenal that would be discerned and legislated upon by philosophy, as it is in Kant. Insofar as science reflects upon itself and becomes philosophy of science, then it must in a certain way systematically destroy the limits that traditional philosophy has imposed upon science. In this way, Bachelard develops an understanding of scientific activity which proceeds without metaphysical or philosophical foundations to produce a realist knowledge of the real through the multiple contingent constructions of its rational forms and experimental techniques. As such, science and scientific experimentation, in a certain manner, always work at a limit or frontier, that between the known and the unknown. They are a kind of ungrounded but realist limit practice in which both sides of the limit of knowledge are always at play. It is here that one can discern a decisive development from Poincaré's hybrid empiricism and a priorism to something like a relational realism. Yet, despite their differences, Bachelard's thinking develops and resonates with key elements of Poincaré's position: metaphysical non-foundationalism and a pragmatic, non-idealist approach that responds to the real in a plurality of technique. Arguably, there is a clear modulated line of scientific thought and cultural practice that runs from Poincaré and the modernist philosophical and aesthetic avant-gardes through to Bachelard, to his successor Georges Canguilhem, who incidentally taught Nancy, and then through to core Nancian concerns. This is a line of thought and practice that is preoccupied with ontological ungroundedness, the relationality and plurality of being, and after Bachelard, with pragmatic realism and a practice of knowledge or thought at the limit. The collaboration between Nancy and Aurélien Barrault in What's These Worlds Coming To can be seen to carry forward and further develop some of the key aspects of this trajectory of modernist science. In a manner that echoes conventionalism and its affirmation of plural geometrical approaches to reality, Barrault affirms the plurality of scientific theory and the loss of unitary and universal laws within contemporary physics. He notes that, I quote, the profusion of complementary theories constitute a plural numeric and numeral dynamic, and thereby suggest an irreducible disunity that is characteristic of contemporary science as a whole. This is borne out, he argues, in, I quote, the coexistence of models that pertain to the same phenomena. In this regard, Bauer cites a number of theories relating to quantum gravity, all of which offer variable and differing explanations of the same observational results. This leads him to conclude, with regard to the multiplicity of theories within fundamental physics, that no model can be absolutely and eternally correct. The anti-metaphysical, anti-foundationalist posture of Nancy and Barrault in this text is summed up, I think, in the concept of struction, which once again returns this discussion to the modernist preoccupation with technique and technicity. Struction, deprived of the prefix con that might imply a reciprocity of correlation, a reciprocity or correlation of relation, describes the structuring of structure, or structuration as such, in and out of relationality. It gives an image of the cosmos as a reticulated structuration of relations to that are never held in reserve or returned to a unity or identity of being. In this context, human technicity, technique, or technology, Nancy argues, is not an artificial supplement to physical nature, but rather, I quote, has a place within nature. It is one of nature's ends because it is from nature that the animal capable of technology is born, end quote. Human technical capacity, its invention of art, technology, science, and the diverse techniques proper to each is understood here as an extension of nature, of the struction of the cosmos. This closely echoes the thinking of Bachelar's successor, Canguilhem, elaborated in his essays such as Machine and Organism. In this view, all human activity or production, artistic, scientific, but also social, cultural, political, and economic, should be understood in the mode of technical struction, which prolongs the profusion of physical and biological struction into what we understand to be the human sphere, but which is in fact nothing other than an extension of nature and its web of physical and meaningful relations. This is no longer the perspective of constructivism, where forms are made according to all too human-centered artifice, because the human is no longer centered on itself, but is rather dispersed back in its relations with the natural world that both precede and constitute it as such. Struction is an ungrounded and fragmentary production, reticulating the wider web of relationality that form both nature and the cosmos. Yet cosmos here is no longer understood as an orderly, harmonious system. As Nancy puts it, I quote, "Struction offers a disorder that is neither the contrary nor the destruction or ruin of order. It is situated somewhere else in what we call contingency, fortuity, dispersion, or errancy," end quote. If the positions of Nancy the philosopher and Barrow the physicist resonate with the trajectory of modernist science that has been traced here, they can also be aligned with a number of orientations and theories within contemporary science and scientific thought. One might cite the cosmologist Lee Smolin here, or with caveats, the ontic structural realism of James Ladyman and Don Ross, the latter being traceable in a direct line back to Poincaré. I've discussed these at length in my recent book, The Technique of Thought. Perhaps the most relevant in this context, however, is the resonance the concept of struction might have with Carlo Rovelli's relational quantum mechanics. Rovelli's theory takes as its starting point the idea that all the seemingly intractable problems or paradoxes of quantum theory are likely to be resolved if we accept the experimental results of quantum formalism, but rethink the ideas or presuppositions through which those results have been interpreted. The problems and paradoxes in question relate most obviously to the so-called measurement problem, questions of wave collapse and decoherence, the superposition of quantum states, and generally the roles of observation, mind, and independent reality in quantum experimentation. Rovelli's key insight is that the notion of an absolute state of a quantum system, a state which would exist independently without any relations to an observer, is entirely erroneous. And crucially here, by observer, Rovelli understands any other quantum system with which a given system is in relation, and not exclusively the human observers present in the measurement of scientific experimentation. Quantum systems are always in interaction with other quantum systems, and the scientific measurements of quantum mechanics are but one form of interaction. And no one interaction will be the same as another in such a way that two different observers of the same system might obtain different outcomes. In short, there is never any observer-independent state at the quantum level. This is just as true for the scientist who, observing a quantum system, determines information relating to that system, as it is for the stone, which, positioned in such and such a manner in relation to its environment, and in the absence of any human observer, nevertheless has information because it points in this or that direction. In each case, there is a transmission of information in relation to a surrounding environment. Rovelli uses the Shannon concept of information as imported into physics by figures such as John Archibald Wheeler. According to this model, the world is made up of relations all the way down from the macro to the micro level. If we understand this, then all the problems of quantum physics appear differently, and elements from many of the competing theories of microphysics are confirmed despite their contradictory aspects. And it's interesting to note that Rovelli, invoking a key moment of scientific modernism, suggests that his theories for quantum mechanics, what Einstein's special relativity in 1905 was for the interpretation of Lorentz transformations in the context of relative movements through space-time. To conclude, this then is an entangled universe in which all things are constituted as such in their relations with each other. In the transmission of information for Rovelli, or following Nancy and Barrault, in the relations of structure. Aligning Rovelli with Nancy, I would characterize the resulting perspective as a relational realism that runs on parallel lines at the respective limits of scientific knowledge and philosophical thought. This is a realism in which relations of any kind are already relations of knowledge, simultaneously ontological and epistemological, real relations to a real from which something comes or is imposed, or to which any given relation is exposed. Rovelli, in the Discourse of Physical Science, speaks of the transmission of information. Nancy, in his philosophy, of the exposure and inscription of relational sense. I'm not arguing for an identity between the two concepts of information and sense. But as I argued in the technique of thought, the scientific concept of information inscribes as the quantitative determination of physical matter what Nancy ascribes as a qualitative indetermination of sense understood as matter. And now I would add as the structure of the real. Between Rovelli's informational and inscriptive determination of matter and Nancy's ascription of sense as matter, the relational realism that has been outlined here emerges. This realism arguably continues the radical legacy of modernist science and continues also its legacy of plural technique across the domains of science, thought, and culture. It also, and finally, returns human technique to the place it never really left anyway, the structure and reticulated web of relations that constitute cosmological, physical, and biological existence. Thank you.
Thank you very much, Ian. We have time for one or two questions before a short break. Artemi and then Georgios.
Yeah, thanks so much. Very rich intervention. I totally agree with everything except that, well, you kind of said that, but I think it should be more emphasized that precisely Nancy emphasizes the relations as a certain impossibility. Relation is always a crisis. That because otherwise you could just replace the world of objects with a world of relations, of predicates. It would be an idealism. But Nancy says that relation means that you negate yourself. He has this kind of Hegelian dialectical attitude to relation. That's why when we with science, when we introduce some sort of structuralism, we are naive. Only some kind of chaotic understanding of structure, which by the way brings us back to Miyasu, whom Susanna just rejected, may make sense of this conceptual shift. Thank you.
Thanks. Yeah, probably I could have made it more explicit, but nevertheless, I think, and there's an interesting debate between Graham Harman and Nancy on this point. If you read Le Cœur des Choses and other bits where Nancy talks about things, my reading is that he does think of things composed of relations all the way down. And so that there are no independently existing objects that come into relation, but that relations form objects. He talks about matter differentiating itself in relationality. And I think it's very easy for a purely sort of relational and structural account to fall into idealism. And what happens, I think, in the trajectory of modernist science is that kind of modernist mathematics actually becomes structuralism in mathematics and a kind of Platonism in mathematics. Just as I think you see certain kinds of relationality within modernism evolving into structuralism. And it's not by chance that Nancy and Derrida in the 60s are challenging that notion of structure to give what we then know to be post-structuralism. So I agree with what you say, but I do think, and it takes probably more mapping out than I have been able to do here, that you can have a purely relational account, as you find in Routledge and I think in Nancy, which is still a realism. It has to deal with the idea of the limit of thought and maintain a sense of finitude, going back to what Susanna was saying about the difference between Nancy and new materialism, which I totally agree with. And so that's kind of how I respond to that. But there is a lot to talk about there. And so it will be interesting at some point to do so.